Now, the stars and star clusters form our galaxy, the Milky Way, which is a translation in English of Latin term Via Lactea. Also, Greeks called it Galaxia Cuculus, meaning milky circle. So, where the name comes from? Certainly, ancients didn't know that we live in the disk of stars that is called the Milky Way. Well, if you go away from the city lights, from any kind of light pollution, and you look up in the sky, you will see this diffuse band of light across the sky. This is what was observed by Greeks and Romans and other civilizations, and this is what we call the Milky Way. Of course, Greeks and Romans didn't know what it was, and the first clue as to what it is came when, in 1609, Galileo pointed for the first time telescope into the night sky to observe it. He did not invent the telescope, but he was the first to use telescope in astronomical observations. So, viewing this band of light through the telescope, he realized that it actually consists of very many faint stars. And from that, he concluded correctly that they are faint because they are at great distance from us. And you can understand that from the following analogy. If you are driving at night along the straight road, it's a two-way road, and there's a car approaching you, when that car is a great distance from you, its headlights appear only as two faint dots. And as you approach each other, the headlights become brighter and brighter, simply because the distance between you and the other car is decreasing, and you start receiving more light from its headlights. So the same thing is here, because these stars forming this diffuse band of light are so far away, they are very faint. And of course, ancients didn't know, and even Galileo didn't realize what is going on. Why do we see what we see when we look at the Milky Way? And it was later famous German philosopher Immanuel Kant, and then Thomas Wright in England. They concluded correctly that we see what we see because we live in a disk of stars. And let me try to explain that with the following diagram. If we have disk-shaped region filled with stars, then if we look along the plane of the disk, we see many more stars than if we look out of the plane. So when you observe the Milky Way, when you're looking right in the direction of this diffuse band of light, you're looking in the plane of the disk of stars. When you look away from this band, you're looking out of the plane. And hence, if you look along the plane of the disk, you see more stars than if you look in the direction out of the plane. It turns out that the diameter of the Milky Way is about 100,000 light years, and our distance from the center of our galaxy is about 30,000 light years. Now, how do we know that? Well, that was concluded in the first quarter of the 20th century. An American astronomer, Harlow Shapley, measured the distance between us and these globular clusters that surround the galactic center. Turns out that the center of the galaxy is in direction of constellation Sagittarius, and he realized that about 50% of all these globular clusters, these dots here, on the diagram above and below the plane of the Milky Way. He was able to measure the distance to them, and assuming that they are actually distributed uniformly around the center of the galaxy, he was then able, using the simple geometry, the same method that surveyors use, he was able to deduce approximately the distance between us and the center of our galaxy. Here is the artist's image of what one would see if one would observe our galaxy from above the galactic plane. There's the central bulge region, the disk. The region above and below the disk is called halo, which is filled with globular clusters. And it turns out that our galaxy has these spiral arms, which are outlined by very hot, luminous young stars.